And now I can welcome some guests from the VVM project, from a second project, the verification and validation methods. We will hear a presentation about the cooperation of the two projects towards a comprehensive framework for autonomous driving safety insurance. And this presentation will be held by 3 speakers. The first is Mark Schiementz. He is expert for automated driving at BMW. And he is the co-coordinator of the VVM project. Second speaker will be Christian Neurohr. He works at OFFIS in Oldenburg, and there he is a senior researcher. He as well is working in the VVM project, and there he leads the part project Criticality Analysis. And the third presenter now will be Henning Mosebach, Dr. Henning Mosebach. He is the research manager for automated mobility at the German Aerospace Center, DLR. And there he is at the Institute of Transportation Systems, the acting head of research strategy. In the SET Level project and in the VVM project, he is responsible for knowledge transfer and international dissemination. So all the 3 of you, a warm welcome, and we're looking forward to your presentation. The stage is yours.
So now,
yes.
Sorry, the window disappeared magically. So I have to go back to the presentation. So, okay. As already introduced, well, my name is Mark Schiementz, and I'm one of the 2 overall project coordinators of the research project V&V Methods. And together with my colleagues Christian Neurohr from the Institute Office and Henning Mosebach from the DLR, we want to give you a brief insight into the project V&V Methods, and especially show an example for the close interlink and cooperation between SET Level and V&V Methods. Important to know is that the project SET Level and V&V Methods share a common history. Both projects were actually planned as one great project, but finally had to be divided due to administrative funding reasons. Both projects are continuing the work of the initial Pegasus project under the new name Pegasus Family. In the years 2016 up to 2019, the original Pegasus project was working on the safety assurance of automated driving, especially in a highway environment. V&V Methods extends these results to an urban environment and addresses important needs that are still popping up on this topic today. While SET Level is working on the simulation side of the safety assurance, the central goal of V&V Methods is to develop a comprehensive framework of methods for the validation. This includes a central safety argumentation, also deriving methods herefore, and proves this verification and validation process by different urban example use cases. The main challenge of V&V Methods is to prove the safety of the autonomous driving function, mastering the open context of the driving task. This corresponds to mastering an extremely large test space in the validation process. The simulation will play therefore an important role and deploys major evidence within this proof of safety. V&V Methods is also building up common interfaces, enabling the important exchange between the different parties involved in such a process. And it's a complex validation process, and there may be players like OEMs, tier ones, databases, maybe public databases, and maybe also authorities. In the following, I want to introduce the V&V Methods project architecture as well as the interlink with SET Level. First of all, V&V Methods consists of a general framework addressing the overall process, and well, yes, these are setting the boundary conditions and starting points of the project. Additionally, we have 2 major workflows that exist within the project. The first one is developing a comprehensive safety argumentation for autonomous driving and a concrete overall test concept, including an example realization in a test infrastructure. The second workflow is generating the informational basis for these concepts in order to provide evidence for the validation process. And as you can see, SET Level with its simulation methods and technology plays a central role. And in the following, I want to show this close interlink between these concepts as well as in a concrete example by Christian Neurohr. As a starting point, you know this picture. As a starting point for this interlink, you can see here the simulation-based engineering task as developed within SET Level. These will be applied in the following safety argumentation within V&V methods. This safety argumentation consists of 3 layers representing different perspectives and different grades of abstraction. The capability layer derives the claims from different sources, for example, laws, standards, or guidelines, but also from information about the open context of the driving task. This layer applies method of the simulation-based engineering task of SET Level. The next abstraction layer is the engineering layer, and it includes the design and implementation of these capabilities and verifies these in a controlled test environment. This layer applies the simulation-based optimization task for system design, as well as simulation-based testing. Finally, there's the real-world layer, and it has obviously no direct link to the simulation since it doesn't include simulation models at all. In the following, we want to give a concrete example how this simulation-based analysis of SET Level is applied within the capability layer of V&V methods. Before focusing on the concrete example, I want to give a quick insight on the decomposition of claims within the safety argumentation. A high-level claim is systematically decomposed into several subclaims. But what does that mean? For example, the claim may be an overall positive risk balance. We want to show this overall positive risk balance of the autonomous driving function. Then one corresponding subclaim may be that the accident rate is lower than a certain reference, for example, accident statistics or average human performance. The goal is now to obtain evidence for this subclaim and thus also for the claim, for example, by applying simulation methods. So these claims serve as a basis to derive concrete simulation engineering tasks. This can be solved by methods of SET Level, by deriving requirements for simulation objectives, simulation environment, and by the definition of the system under test. In the following, my colleague Christian Neurohr will give an example for such a simulation-based analysis within V&V methods by applying these SET Level results. And now I want to hand over to Christian.
Well, thank you, Mark. Yeah, as already indicated, I will now talk about the criticality analysis in V&V methods. In SET Level, the criticality analysis is a simulation use case, as you might know from the presentation earlier this day. So now we want to specifically look at how does criticality analysis actually contribute to the safety argumentation. So the overall claim of our sub-project is that we identified and analyzed the relevant influencing factors on criticality in the operational domain, so the urban intersection in the case of V&V methods. Then we have arguments to actually substantiate that claim, and it's along the lines of the criticality analysis is a sound method, and the resulting artifacts are sufficiently complete and, of course, substantiated by evidences. So the artifacts, and that was already mentioned by Arun this morning, that result from the criticality analysis are the associations with criticality that are called criticality phenomena, causal relations explaining those phenomena, and in the end, also abstract scenarios that feature these phenomena and the causal relations as well. In order to actually conduct such an analysis, we require several tools. Besides criticality metrics and also ontologies, the focus today will be on the simulation. So how do we actually use the simulation for criticality analysis? And other tools include the acquisition and management of knowledge and data, and of course the analysis of data. And this includes, of course, real-world data as well as synthetic data. So yeah, this picture was also shown by Arun in the simulation use case 1 presentation this morning, but here I will elaborate a bit on it. So we start with the phenomenon, and in the following it will be the phenomenon occlusion. So yeah, two objects cannot see each other because there's a visual obstruction. So this might be identified either via data or expert knowledge, and so the really the basic concept is to improve our understanding until we can say we have found a plausible causality explaining the phenomenon. And this is done by an intertwining process of data analysis, and then of course infusing these analysis with expert knowledge. On the way of improving our understanding, we will need to acquire new data because we will probably identify a lack of data, and also update tools. So a lot of requirements result from actually improving our understanding. And this specifically calls for updates of the simulation of metrics and our ontology. And the convergence criteria for this overall process is defined relative to the phenomena that are actually contained in our overall database. In order for this process to actually deliver a sound result, we have two core assumptions. So the first one is that the set of phenomena is limited and manageable. This is justified by the simple fact that humans are somehow able to drive relatively safely by recognizing a limited amount of abstract classes of danger. So this assumption gives us finiteness of the artifacts produced by the criticality analysis. The second assumption is that the relevant phenomena will leave traces in the growing databases. So once data for automated vehicles keeps accumulating, we will actually see what are the relevant phenomena, and this will lead to completeness of the artifacts. So now we go into the details of a specific simulation-based analysis task within the VVM methods criticality analysis. So the minimal required functionality is really sampling from large scenario classes, execution of concrete scenarios, and also the evaluation of criticality metrics. So these are all provided by SET Level use case 1, and we had a very nice talk earlier this day about this. So the V&V method criticality analysis really builds on top of these minimal required functionality of simulation. So we want to use this for the plausibilization of causal relations. So is our explanation of phenomena really sufficient, and simulation can help with that, especially quantification of effect size. The effect size of phenomena is enabled by this. Another very important point is actually gaining more understanding about criticality metrics. This includes the engineering and the calibration and comparison of and between those metrics. And another very interesting point is the abstraction and refinement of criticality phenomena and causal relations. Especially these interaction between abstraction and refinement is very important to actually achieve finiteness of artifacts. For the remainder of my talk, we will focus on the plausibilization of causal relations. On the right, you can see a very complicated graph that actually represents the causal relation for the phenomenon occlusion. I won't be going into details here, just so you have an idea what I'm talking about. So let's just assume the task for our simulation-based analysis is to generate evidences for this causal relation. So for us to understand, did we really get the essence of the phenomenon, the occlusion phenomenon? And the approach is the following. We start with an abstract scenario that actually features a static occlusion. So this traffic sequence chart here is really based on a functional use case in V&V methods, and it's an occluded bicyclist illegitimately crossing a pedestrian crossing and an automated vehicle approaching. And of course, we don't want to hit the bicyclist. So in order to get this to simulation, we derive a set of associated logical scenarios. So we can actually use simulation software such as OpenPath or Scala to run this example. On the right, you can see an exemplary parameter space that has been derived from this abstract scenario. And a very important point is that actually we do not randomly choose parameters for variation, but instead we systematically derive these parameters by confounder analysis of the causal graph that represents the hypothesis about the causal relation. So we continue with our approach, and this is really well known. So of course we use a variation of parameters to obtain concrete scenarios from this parameterized logical scenario space, and then execute these concrete scenarios in a simulation and evaluate suitable criticality metrics. And of course this can be any number of desirable metrics. So on the right, I included some graphics on the evaluation of criticality metrics over time. On the left, a critical occlusion scenario versus a uncritical non-occlusion scenario, and the metrics evaluated here are on the one hand a modification of the required acceleration and a predictive version of the post-encroachment time. These are quite interesting metrics, and more on this can be found in our publication on the criticality analysis. And then the generated data set from, let's say, 1,000 or however many runs that you actually want to execute. One example of data analysis is the following. So for each run, we can evaluate was the occlusion phenomenon present or not, which gives us a separation of the data set according to this random variable. And we can then, of course, in the afterwards perform statistical analysis of the resulting data set, and from this derive all kinds of interesting quantitative statements about our phenomenon. So here you can see that well, in our simulation, the occlusion scenarios have a lot of critical spikes, whereas the non-occlusion scenarios require almost no strong braking maneuvers in order to avoid a collision. Other interesting things are computing expected values and standard deviations, or quantifying the effect size of the causality on the required acceleration, such as computing a Cohen's d, or seeing that the required acceleration is about 3 times higher for occlusion scenarios. And then, of course, a very standard practice is that you might actually want to compute correlations between certain variables in your scenario and the metric as an outcome variable. So let us resume. How did simulation contribute in this very brief example? So the original claim of the criticality analysis was that we identified and analyzed all the criticality phenomena in the operational domain. So a subclaim of this is, of course, that we did the same thing for one specific phenomenon, in our case, the relevant phenomenon occlusion, and analyzed and understood its effect in a specific urban intersection scenario. So this is really just one atom, one part of the claim of the criticality analysis overall. And now the simulation was used to provide a little bit of evidence for this. And for the causal relation occlusion that we checked using simulation. Of course, this is not enough. We cannot say we understood the phenomenon solely relying on simulation. We of course have to check and with real world data and make sure that what we did is valid. But still, though, simulation provides us with evidence here. And of course, it also enables statistical analysis by generating data, and also very importantly, quantification of the effect size of occlusion. So now we leave the criticality analysis again and go back to the overall picture, and I will have a little summary about the relationship between SET level and VVM method on the other side. So the data that is generated from simulation can be used as evidences for the safety argumentation. So the safety argumentation is really one of the central goals of VVM methods, and yeah, as already mentioned by Mark, and as I showed in the criticality analysis example, simulation can be used for this. On the other hand, claims arguments and system data of the VVM methods argumentation supply the simulation with objectives and an environment as well as a system under test, serving as a requirement machinery in that regard. And Mark also mentioned this, the engineering tests of that level, they fit very nicely in the layer model of the safety argumentation of VVM methods so far. And well, for the future, we're really looking at increasing the exchange of models, simulation models, and also scenario descriptions between the two projects. And now I think my colleague Henning finishes with some international perspectives on the VVM methods project.
Thank you very much, Christian and Mark, for this very deep insight into the project verification and validation methods. So thank you. So what I'd now like would do is to give you some more context, because the whole technical details you have heard today, so many deep insights into simulation-based testing and all the scenario transfer around it. It is not only a bunch of strong companies from science and from the industry you see here that are working together in both projects, SET level and verification validation methods. There's also the intention to regard this as follow-up projects of the Pegasus project. We call it Pegasus family. And what is really a very important, let's say, dissemination issue of both projects is that we are planning to very early share our preliminary results and new ideas with you, with the outer world. And for example, these are mainly three main blocks. First of all methodologies and concepts and also architectures, how we could transfer real test scenarios into a simulation environment, and how do we have to describe our parameters in a way that they can be measured or that they are accessible. This is a really important point that we are planning to share very early our ideas and our concepts with you. For sure, we first have a first iteration within the projects, within SET level and verification validation methods. And I think today is a really important day for that, because we have now a bunch of new results from SET level, and I'm pretty sure that this will stimulate questions by you, by the community, and will come back to us. So plan is that we share our results with you in the early stage, and that we not only share our results, but we also want to show you our proof of concepts, how we used open standards, open tools, and other description models that are open available. So this is an important point. And we see 4 main channels how to get an interaction with the whole world. First of all, we want to share this in an informal way, discussing with technical experts, so with you who are here today in this call, which we call communities. So an informal exchange within the communities is the first important step for us, and we are already active in this area. Then for sure we want to have an impact on potential certification processes, so that you can see some examples from our side how the future homologation procedure could be supported by our results. Maybe during this year we'll have more concepts about that coming up. For sure, standards are an important issue. We want to intervene with the standards. We are already involved in standardization activities. This means this is bi-directional, so we for sure take existing standards into account and standards we are knowing of, but also we will have an input in them. And for sure, regulation is the next issue coming up this year. So the main message here is that we want to share quite early, and today is an important day for that. if you are planning to meet us again in the future, because you are curious now, and maybe you was it even before, there are several ways to meet us, so verification based methods, and for sure SET Level again. First of all, for sure on our project and networking websites, SET Level, verification based method project. The old Pegasus project as well, it's still alive, this site. And what is quite new, this transfer project exchange, which I am leading, and also my colleague Sven Hallerbach, we are going to release new proof of concepts from both projects and maybe from the community as well. So this is one opportunity. Second, we are already active in ISO standardization working groups in ASM for sure. Also, we are going to build up a conversation with UNEC Work Package 29 during this year. This is very important. We also have, and maybe this is most interesting for you, we already have some bilateral exchange meetings, e.g. with Sakura, with Head Start in Europe, with the Pegasus network in the US with NHTSA, also some German projects and some European initiatives. So we are quite open to already have a short workshop and just exchange our opinion without any contracts. Make this open, because you may have heard today on several times that both projects are intending to use open context, open standards, and open tools as much as possible. So we do not develop products, but proof of concepts, and show how we implemented simulation-based issues and so on. And for sure, we are active on many conferences and workshops. So maybe the four most important ones this year is today, the midterm presentation of SET Level. Then we are planning, still under discussion, we're planning to have a contribution on the Automated Road Transport Symposium in US. This year it is called ARTS, Automated Road Transport Symposium. This is for this year based due to Corona. It's a substitution of the ABS, but it's more or less the same. This is mid of July. We have applied for our own session in Hamburg on the ITS World called Tools and Methods, where we want to show in the most concrete way as possible which is the current tool and method family we're going to use. And it would be great to also be present like last year's at the SIP Artist Workshop in Tokyo, November this year. But we have in between many other events which you also will be announced on our websites you see above. Okay, so I hope this give a new, let's say, angle on the day-to-day, that the Pegasus family is not only generating content, but is also willing to share this with you and to be linked to you and to improve this in the future. Okay, so Verena, thank you very much. I would now hand over to you, and it's your turn to proceed. Thank you.
And I think we can start with your interaction with the audience right now with maybe 2 questions that we have time left for. So Frank Köster, you are with us again. Can you get some questions out of the audience and address them to our speakers?
Yeah, there was one question to Christian regarding the field of view of the perception sensors in your approach. So how do you consider the combined field of view of the perception sensors in your approach?
Does this question relate to a specific slide or?
Not mentioned, so
no. So for our initial experience, for our initial experiments, we just took a very simple model that has a camera sensor with about a 90-degree angle to the front. And of course, this impacts heavily the effect of the occlusion phenomenon. But in for the following iterations, we will look at actually using much more realistic models for the criticality analysis as well. In particular, we want to use the models that are developed by SET Level and will be provided and be available for V&V methods, I think, following this event. So this will be another exciting possibility for cooperation between the projects to actually incorporate the models offset level in our methodology.
So now I have an additional question regarding the evidence, I would like to say. So how do you make sure that the criticality observed within your simulation runs is actually resulting from the observed phenomenon rather than from model inaccuracies, uncertainties, or from simulation tool limitations? So I don't know who wants to pick up this question. So Mark, Christian.
I think it relates to the criticality slides as well. So this is of course a very interesting question. So concerning the simulation environment, this of course relates to the problem of validity of the simulation as a whole. So I think solving this is part of a bigger problem, and I mean, this is part of the problem of, well, is simulation valid so we can use it for any part of the safety argumentation for automated vehicles? And concerning the models, this is the same problem. So for criticality analysis, we aim at using somewhat realistic models, and since it's not really bound to one system under test, the validity of our simulative parts would be greatly enhanced if we did the same analysis while varying models. So if we can show the effect of the occlusion phenomenon across a variety of different models for automated driving functions, say 2, 3, 4, or even 10, this would of course really substantiate the results. Yeah.
Okay. Thank you very much, all of you, Mark, Christian, and Henning, and Frank as well, for your presentation. It was a pleasure.